Hey, what's going on, folks? It's Mike here, and welcome back to my SDL3 programming series. Today we're going to be taking a look at one of my favorite topics, which is sprite animation. So here's the basic idea with sprite animation. We're going to take some image like this, here's a recognizable character, Mario, and load a different sprite sheet. That is a series of sprites, oftentimes on the same texture, or you could also do this on the CPU side if you wanted to do this with a surface and blit each successive image. But the basic idea is that we'll take from the same texture and sample one different section each time. So we'll be actually taking advantage of this source over my shoulder. Let me go ahead and move out of the way here, and updating where we're selecting from the actual texture. And if I do this over and over and over again, you will see in animation here. Now this is just on PowerPoint, so it's not as nice here, but if I go ahead and focus your attention towards the top right of the screen here and play this back again, watch how as I update the source where I'm selecting from, so each successive image, I get a new frame of animation here. So that's the basic idea, simple enough to understand, and let's go ahead and get started. So what are we going to need to do? Well, let me go ahead and flip to our code. And what we're going to need to do here is in our sprite abstraction, which we've created in the previous lessons, so make sure you check those out if you haven't. We're basically going to need to update either our render function or perhaps add another function that animates our sprite here. So it could work either way here, but currently when we have this null pointer here, that basically just means select the whole selection of our texture here. And our destination is again where we're drawing. So again, the destination parameter of our render texture says where do we draw and how large of a image do we draw, and we can scale that up or down based off of our width and height of the actual rectangle here. But again, the source is selecting from the actual texture here. Now we have a little bit of a problem in the sense that if we run our program here, we'll go ahead and see that, well, we just have this one image of this person here. So we're going to need some series of images that we can render. Now, again, I will caveat that it's probably more optimal to, again, have each frame of the animation on the same texture, because what we could do is have a bunch of different images and then have maybe an array or a vector of textures here. But that's often a lot of different state changes if we have to change a texture. So that's why we cram all of the pixel data into just one image typically. It's less state changes on the hardware. And in this series, we're not trying to be super efficient, but we do want to point out some of these things because they'll be important for you as you build your own abstractions. And I want you to build cool games later on and get good performance. So anyways, with that said here, let's see if we can find some animated sprite sheet. And basically, you can search for this term like royalty-free sprite sheets if you're just learning, or you could pay for some if you're willing to do that. But what I found here, there's lots of different free assets, but I found this cool one here, Universal LPC Spritesheet. And if you go ahead and click on the GitHub link here in the top left, you can learn a little bit about this project. But basically, it's a sprite sheet character generator here. So I'm just going to use this for this example, and you can also search this and find it if you want to follow along. I do want to just point out the mention about the artwork and the various licenses, so pay attention to that if you are going to use this for some sort of commercial game, or otherwise make sure to get in touch with the authors of this tool. But basically, it'll generate something like this here. Now we've got this character here, and you can see the preview of the walk cycle. But it gives us a bunch of different options on how we can just tweak things. And I just want to get us started with something. So let's create, I'm just going to select a male here, and there's tons of options here. Let's make them green, maybe even blue here, just for fun. And again, this is just kind of a cool tool. We're not going to spend too much time here. Let's give them some, we could give them some wings or something. Let's see what we have here. So there's all sorts of options here. Carrot wings, and let's see here. Let's give them some pants at some point. Let's see, pants. I'll give them long pants, and I don't know, just something like this here, black pants. So anyways, here's our little sprite animation. And again, you can see the tool that does a nice job here of generating these things. So maybe this would be a fun tool for you to also try to build or recreate, or of course you can make your own pixel art. So anyways, we'll have this blue guy with red wings flying around, whatever, however you want to define that here. But these are all the sort of animations here, one after the other. Now we'll need to figure out the dimensions of these. And again, this is something just to keep in mind as the programmer to talk to your artists and say, what kind of dimensions are you going to make things? Make sure that they're all the same size. That's a little bit easier, or maybe there will be a spec. And otherwise, figuring out the exact rows and dimensions of these things might be something that's also exported in like a JSON file or something that kind of says, hey, this is the, let's scroll up here, the walk cycle, or maybe you define like the sit cycle. And have some metadata associated with the actual pixel data here. Okay, so again, that's just a little bit more on the engine side, so you learn a little bit about what's going on, but we'll try to get a little run or a walk animation here. So anyways, I'm just going to export this out as a PNG image here, and we'll open that up. And let's see what we got here. I'm just going to, I dropped it in my assets folder here. And again, just a little bit on project structure here. Let's go ahead and zoom in on this. We get all these sprite sheets, and this is a PNG image. So if you're not familiar, PNG is a format that has transparency. I'm probably just going to convert this into a bitmap and then give it the sort of pink background that we did before, and then use a color key. There is SDL image, which is a library that can load PNGs and preserve the transparency. So I'll probably do a video on that. You can probably find in this playlist if you're watching this, months into the future after this has been released. But anyways, we can see our sprite sheet here. Now again, there's a lot of sprites here, and well, we don't exactly know the dimensions. So we can either chop one of these off here. Again, we know the dimensions of the whole image here, but let me see if there are some other export things we can do here. It looks like we can get a full image pack here. Let's see if I can split by animation and export that out here. So there's a few different options. Again, this is a pretty neat tool. And if I open this up again, I'll get a export of this. This might be a little bit easier to work with. And again, I'm just going to dump this into the assets. So I extracted this out here. And again, credits to the authors here. Let's just go ahead and show that one more time here for building this cool tool. We're just going to use this for learning purposes, but again, keep this in mind if you want to use this. I believe this project came out of an open art competition. So again, some neat things there. But let's see what we got here. Our standard animations, and this is going to be a little bit easier to work with. Now we've got them in a simple sprite sheet here. Let's just work with this walk PNG, for instance. And let's zoom in here, and we're just going to grab maybe one of these where he's walking or whatever this character is to the left or to the right here. Now I'll show you a trick maybe in a future video here where you don't need to have walk animations going to the left and to the right, and this will actually save some memory. Maybe I'll show that in the next video because you can actually flip the animations if they're mirrored. So again, there's all sorts of neat little tricks here. But let's work with this one. We have the dimensions here. It looks like it's 576 by 256 pixels. So every row is probably 64 pixels high. And then I'll do the math of 1, 2, 3, 4, 5, 6, 7, 8, 9 images. So maybe that's 128 pixels wide or something like that here. Well, we'll do a guess here. So anyways, let's extract out this walk here. In whatever character that you created, do a walk here. I'm going to go ahead and open this up with GIMP here and just export this out in case you have an image. I just want to work with bitmap images for now because that's what SDL supports. So let's paste in this. Basically, this is a 255 by 255 in the red and the blue channels here. I'm just going to use the bucket tool to give a flood fill here. Looks like it did a nice job here. And then export this back out as walk BMP. Just so we could work with this sprite here. Let's see, the RGB format, let's just make this 24-bit red, green, blue. I think that's probably what we want here. That'll do the trick here. And it probably doesn't matter, but you need to, maybe experiment with that a little bit. And if you want, just to make things easier, you could probably even trim one of those rows out, but I think this will be a nice example for us to work with. So anyways, let's go ahead and just start by, in our application here, finding where we work with our sprite here, which was character BMP. Let's switch it to walk here, okay? And we know the dimensions, the position doesn't matter so much. Maybe let's put it on some, like, I don't know, 32 by 32 is a common tile size here. And the dimensions I said were about maybe 128 by 64 pixels high, something like that. So let's just go ahead and try to run this here. Compile it with the same thing that we've been compiling with. There it is on Linux. You can watch the first videos. Otherwise, if you're struggling compiling. And we got something like this here. Let's see what we got here. Okay, so it's moving along here, but we're drawing the whole image here. Okay, so this is good, and we've got the color key from the previous image, so we ignore the back pixels. But again, what we want to do is just select one of these frames at a time here. So we kind of have to pick out the source there. Okay, so that's what we're going to work on today. And I'm just going to copy this. We'll have a rectangle here, and this is going to be the source. And where we, let's see, I'll just label this as pixels we are selecting to render from on our texture. Okay, so again, that's the basic idea. Again, just to select some subset of these pixels here. Okay, so let's go ahead and again do an example here. And there's a few options you can do here. So we could write a little function here, and let's go ahead and what I'll do here. Let's make sure we put in our m source. There we are. And let's initialize this. How shall we do this here? The sprite dimensions might not necessarily be the same thing. So, and we could hard code this if we want, but we want to think a little bit about the API. And what I mean about that is we could write a function to just select, or change these dimensions every sort of frame. Or we could have an array of like frames here. Okay, so what do I mean by that? I could have a struct here and call it a frame. And basically it'll consist of this guy here. And then what I want here is something like, I'll just use a vector here of frame. And I'll just call this frames. Okay, so basically we'll kind of pre-populate this structure here. This is doing a little bit more, but I think it's maybe pushing you more towards a game here. And again, you might call this like, we could even push this. I mean, we could even push this up here. I mean, there's a few different abstractions that I want to show you, and then we'll just get something working here. But we could call this like an animation, which consists of several frames here, and then have like the animation structure here. I don't know, M animation or something. Right, and basically all this is doing is providing the series of values that we're selecting from. Okay, so again, let's be very clear here. Let's just bring this in and do a little example here, right? So if I'm here, again, all I'm doing with my source here is, just picking like, what are these pixels? Okay, select there, and then select here. You could create a little structure like that to select a series of frames. Again, this is the type of stuff that you'd probably put in a JSON file that would say, okay, select these frames here, and this is part of the walking upwards cycle. Okay, and you'd store the locations of the X and Y position here, and then whatever the width and height is. Because the width and height doesn't have to be uniform, depending on your artist's needs or whatever. It's probably easiest if it is, but again, it doesn't have to be. So anyways, that's the idea here. Let's undo this to make sure we don't mess up our image. But again, these are a few different ideas you can have here. So actually, I am going to do this just so we kind of do it properly. And basically, for our animation here, let's go ahead and populate this. And basically, what I want to do is let's create a constructor here. Oops. That will kind of do everything for us here. So we know we want the width, we know want the height of each frame, and then maybe we want the number of frames here. Okay, and again, this is one of those things that just to make it easy, let's assume that all of our animations are just on one row here, right? So they're all going to look like this here. I think I said we had 9 of them. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 0 through 8, that's 9 frames. Total, that'll sort of work here. Okay. So let's go ahead and write this function here. And basically what I want to do here is sort of for I. Let's be a little bit proper here. I got to use the C++ size t. I equals 0, I less than number of frames, I plus plus. And what I'm going to go ahead and do here is push in a new frame here. So m frames, push back a frame that's going to consist of, well, this guy here. And let's write the constructor. And the frame will consist of the, again, these are floating point positions, the x, the y, of the corner that we're selecting, and then the dimensions here. Okay. And again, if you want to use your modern C++, like I showed, you could go ahead and do msource.x and initialize it to x. I'm just going to do it the simple way here because I know some folks are following along in different languages. So msource x equals x here. Okay, and there's all sorts of things you could do to make this a little bit easier, but let's just go ahead and do this so it's very clear what we are doing here. Y, W, and H here. Okay, so that's a frame, and we want to push back. Well, the x position is going to be I times whatever W is. The height here, let's see here, is just going to be H. Oh, sorry, actually, the width and the height is going to be the same here. But I think we are going to need to pass in, we'll want to pass in the x and the y that we're selecting from here. So I suppose we should also pass that in here. And we'll just do starting x, starting y. Okay. So starting x, starting y position, and then the width and the height here. Okay. Let's see if this compiles here. Let's see if I've made any mistakes here. Of course I have. Oh yeah, because we don't have msource anymore. So a few different mistakes here. Let's just scroll up here at the animation code here. Animation. Okay, did I miss like a semicolon or something? That's kind of what that error looks like here. This looks good. This looks good. Let's see here. Line 31. Ah, okay, for the constructor here. Right here. Okay. Yeah, it never likes these. I mean, should I make it maybe just a member function? Again, these are the types of things that we could debate about here. Here, I'll give it the empty constructor for now and just say set up, let's just call it load frames. Okay, because that's what it's really doing. Okay, let's see. And then, okay, so that's good for me. Okay, so let's set up this animation here. And again, this is part of our sprite here. And again, I'm just going to hard code this for now. For again, I could write a helper function here, but let's just get it working with this guy. Yeah, this is fine. And let's do it after here. So we will set up our animation. So animation load frames. And okay, the starting position is going to be 0, 0 for now. And we approximated it's 128 pixels wide by 64. Is that right? Again, let's go ahead and open up our image in assets, walk BMP. Okay, 576. So here's what I'm going to do here. 576 divided by 9, 64 pixels. Oh, 64 by 64. Okay. What was I thinking? 128. I don't know. Here's 64. Okay, and then the number of frames is 9. Okay, so that's going to load up our animation. We're not going to do anything with it yet. Let's make sure that compiles. Good. Okay. Okay, now we've got the starting x in the starting y position and the width and the height of it, 64 by 64. And every new frame that I push back from the starting position, I want to basically offset by the width here. Okay, the width times whatever I is. Okay, so the starting x, I guess it's going to be plus, yeah, width times I. So the first iteration through, I will be 0 times 64. Okay, so the top left corner, let's see this from our sprite here, will be, again, 0, 0, and then we're going 64 by 64. So that kind of selects this point here. And the next iteration, when I is 1, that's going to move us I times width to the 64th pixel, and then we'll move across here and select this frame here. Okay, so that's our goal. Now we ultimately want to select down here for a walk cycle, but let's just see if we can get any walk cycle working here. Okay, so we've loaded an animation. We've got this nice frame structure for it. And basically, again, all our frame is a bunch of these msource things. So basically our animation consists of a bunch of frames and consists of a bunch of f rectangles here. Okay. If this is too much of a leap, go back to the start of the video where I just did one M source, okay? And in fact, let's go ahead and start implementing this in our update. There's two ways we can do this. We could just have M source, okay, and then we could set it in update. I kind of like that here. Again, maybe there's a little bit more efficient way. We're adding more bytes per sprite here, but let's not worry about that so much here. Which pixels we are selecting from. And this kind of works well because it decouples these two. So basically in my update, what I want to do here is do M source equals M animation. And basically I want to just figure out how can I select my frames here. So I've loaded my frames. And then let's just write something called get frame here. SDL. It's going to just return a rectangle here. Get, I don't know, frame as SDL frect. Okay, so something like that here. Int index. Okay, and all that's going to do is return from our structure here. And these are structs, so these are publicly accessible things here. This will return M frames at the index. And let's do a little bit better with our C++. Let's do .at here, so it'll bounds check it. Index. And then let's get the M source. Okay, so maybe not the most efficient thing. Let's see if it builds here. Let's see here. What errors did we make? Okay, line 72. So let's finish this off here. So our M source will equal M animation dot get frame here, and let's just say frame 7 here. Okay, let's see if that works and does something interesting. Okay, looks like it got from the right frame here. Okay, it's one of these top ones here. Now let's say if we increment it here. And we could probably store some state in our animation. We could say, and this should be a positive value, size t, current frame or something. Okay, let's set that to 0 by default. And we could just say, let's see here, maybe just write a simple function here. Let's set, let's do something like this here. Max frames. Okay, we'll say that's 0. When we load the frames here, we know how many there are. So that's going to be M max frames equals number of frames. Let's just write a function here called play animation. Play animation. And all that's going to do here is, let's just say M current frame plus plus if M current frame is greater than M max frames, then we will reset it back to 0. I'll actually give this a better name here. Let's just call it loop animation. And again, you could specify like the start and the end here or something. There's all sorts of like, again, variations I've seen here. Loop animation or play frames or play specific frame to get this up and running here. But I think this will work nicely. And I guess there's a couple things I could do here. Loop animation, and then I could return this here. No, let's just do loop animation, and then I'll just write a function called, so let's just do this here. If we take no arguments, then it'll just return the current frame here. And current frame. Okay, so I'll have two variations of this here. Get frame as a rectangle, or just get frame. So this returns the current frame that is playing. And this returns a specific frame. Okay, and again, all it's doing is selecting into our vector, which stores the pre-populated SDL rectangles in this frame structure. And I put it in this frame structure. I mean, I could have just made it a SDL rect, because we might want to give these like a name or some state and add rules for if we can transition to them. So again, you can add more abstraction, or just take it away if this is too much here. But I wanted to give a little bit more something here, just to make it interesting here. So basically what I'm going to go ahead and do here is I can get rid of this argument, since we don't need to play a specific frame, and I'll just call on our animation loop animation, okay, which is basically just going to increment from 0 to the number of frames we have, 9, update that every time, and this will just get me the current frame here. So let's see if that works nicely or not. Okay, terminate. We went out of bounds here, so I should have done like if it's greater than max frames minus 1. There we go. All right, and we got our guy running here, doing the run animation. Let's get the proper one though, right? Because we wanted to index from here. So we know it's 64 by 64, so I need to set my starting point to, that would be 0, 64, 0, 128, and 0, 192 here. So let's just go ahead and, where I do the load frames call, change that offset to 192, and do something like this here. Okay, and now we got our guy running and playing the animation here. Okay, now a few things that you might have noticed here that kind of make it interesting is this guy's moving very fast. We're still at 60 frames per second because that's where we've capped things. In fact, if you want to see if this is working more nicely, right? We haven't looked at our game loop in a while here. Let's just crank this up to, like, I don't know, quarter of their frames here, something like this here, 12 frames per second. And that looks like a nicer sprite animation loop here. Looks like we got a little bit of white space, so we could improve our flood fill function. Let's improve that just so we can get it right. But my point is, the other things that you might want to add to your animation structure, just to give you a little bit of insight, because I don't see this as much on other tutorials, is, well, if I have this frame here, and in my animation structure, what are some other things I can add here? I could add like a delay that says, okay, this is how fast to play the frame or how much time to spend here. That could be linear. It could be, every frame just advance. It could be more of a like, you could have some function here that, if your character's about to jump, they spring up slowly and then they move, a few frames faster. So you can give a lot of control over this, right? And this is what commercial games are going to do, and good indie games for their, animation, have some more control and animation curves. And maybe you've played around with some of these things in editors, but these are the type of structures you can have for this type of thing here. Okay, so let me do the last little addition and just fix up our sprite sheet just a little bit here. I'm going to do O to select this. I just did a video on GIMP too. You can find it on my channel here. And let's fill in some of these white spaces just so we have a nice frame animation here. These are the pixels that we want to be transparent. Here, I'll just do them on the actual one we care about. So again, these are little fine touches, but I think it'll look a lot better here. And these are some things that you have to do, or otherwise maybe ask your artist to do to make sure that they look good. The other thing that I'll note here is, it probably would have been just easier to work with a PNG image. So looking at SDL image and compiling and building that also works here. But let's see, I think this is going to look really nice when we fix up all these pixels. But this is also why, just as I'm talking and doing this, it's good if you as a programmer know a little bit of art skills so you know how to communicate these things to your artists as well. So there we go. That's looking pretty good. And let's re-export that out here since we made some changes. And let's go ahead and rerun this before we stop our video. And that's looking nice here. Now he's moving way too fast, and as I mentioned, we could probably improve the animation curves, but there you have it. All right, folks, so there we have it. That was a nice video here. As always, feel free to hop in, follow along with the series if you missed some of the other videos, because we've added a bunch at this point, but hopefully that describes well enough the idea of sprite animation and how things are working otherwise here. But anyways, I hope you enjoyed this video. There we go. There's our guy here moving around here on sprite animation. So we're getting into some exciting stuff here where we have the foundations or the minimal part of a game here. You can load your assets as they're seen, you can animate them, and now we just need to add some like games and rules and maybe a little bit of an interface, and we'll have a full game here. But now you understand every single step and also have an idea about some of the different abstractions for how to get more, let's say, advanced features and control over animation, and what game engines are often providing if you're using a built-in game engine. All right, so anyways, our little guy is running away and saying goodbye, so I guess we should say say goodbye, and otherwise I'll look forward to seeing you in the next episode.